Something we often have to do in biology is to perform dilutions. So dilution, I looked up the definition online, is the process of making a liquid less concentrated or weaker. So that could be a bacterial solution, other sort of cell culture, or it could be a chemical. And to work out how much we're making it less concentrated by, we use something called the dilution factor. And that describes how much you are diluting your solution. So that is equal to the total final volume over the volume of the original solution. And we're going to need that dilution factor to calculate all sorts of things. So let's just use a couple of examples. So first of all, let's think about the lovely refreshing glass of lemon squash. So if you make that up according to the instructions on the bottle, you would use 1 part concentrated squash plus 4 parts water, and so that would give us a 1:4 ratio of squash to water. Let's just draw a nice glass there. Got 1, 2, 3. These are meant to be equal, so we'd have 1 part concentrated squash and then 1, 2, 3, 4 of water. Oops. Okay, so that's meant to represent water, and then this would all mix up, obviously, and everything would be at an even concentration. Alright, so to work out the dilution factor, how much we're using, we need to work out the total final volume here, okay? So there, what we do is add the squash and the water together, so total volume, so that would be 1 part plus 4 parts equals 5 parts, and so we could say that therefore for every 1 part squash, 5 parts total, and therefore that 1/5 of the drink is made up of the squash from the bottle. And our dilution factor is the other way round, so that would be dilution factor, dF, is equal to 5 parts total over 1 part squash, so that's 5. So we'd say that there's a 5-fold dilution, or we could write it 5x dilution. And here I've just been very vague, I've just said 1 part, so it doesn't matter how big the volume of that part is. So we could put, so if we were making up the glass, we'd say we'd have got 100 mils of the squash plus 400 mils of water. So then our total volume would be 500 milliliters, for instance. Then we could do this same calculation with an actual volume, so that would be 100 mils over 500 mils, and etc., and that would work out the same. Okay, so that's the first thing I wanted to talk about. We could do this with a slightly more scientific example. So let's take TAE buffer, which is something you'll be using before too long. So let's imagine we dilute 1 milliliter of concentrated TAE and we add that to 19 mils of water. So that means that for every 1 mil of concentrated TAE, we've got 1 mil plus 19 mils total volume. Because remember, our concentrate here has to be counted in the total volume, so that's 1 out of 20. So 1/20th of the buffer is concentrated TAE, and then our dilution factor is the other way around, so dilution factor is equal to the total volume over the original volume. So that is 20 over 20 mils over 1 mil, so that means we've got a 20-fold dilution. So there we're doing it with actual volumes rather than just with this nebulous 1 part this, 2 parts that.